All right, this video is going to conclude all of our hypothesis testing with what we do with dependent samples. So this study was conducted to investigate the effectiveness of hypnotism in reducing pain. The lower score indicates less pain, and we have a before and an after score. Differences have a normal distribution. That's nice because we only have 8 subjects here. We want to know, does the after score, right, have a lower score? Okay, so do the sensory measurements on average lower after you have been hypnotized? So what makes this a dependent samples is like each and every subject has a before and an after score. And so I have to actually look at the differences for each person. And it's not going to, and even though there are 2 measurements and it looks like there's going to be 2 means, we're actually going to run this as a 1 sample test because there was only 1 sample of subjects here. So n is equal to 8. We have 1 sample with 2 measurements each. So we call this a dependent samples test. All right, so we can still say like mu b is the true average sensory score before hypnotism, and mu b or mu a is the true average sensory score after hypnotism. But what I'm really interested in is mu little d, which is the true difference in sensory scores before and after that hypnotism, right? And if we want them to be lower than when I do before minus after, and I want the after score to be smaller, then I want to know, are these scores greater than 0? So that's going to be my test here. Right? If the before score is greater than the after score, then we would be able to prove this here, or that the after is less, right? Okay, I'm going to split screen. Oh, not yet. Let's set this up. So I'm running a right-tailed test. Alpha is all over on this side. And I'm running a t-test, so I'm going to, because I don't know the population standard deviations, so I'm going to let StatCrunch do all of that work for me to find my critical value. Ooh, too far. And again, the X bar D has like 2 places it can be, right? Like that's where I'm trying to figure out is how far away is that difference from 0. Okay, now I'm going to split screen. Let me get that set up. And let's go ahead and input this data into our variable 1. So we want all the before scores to go into row or column 1. So that's a little bit tricky. I need row 1 to go into column 1. So I need to like transpose that, if you will. Okay, and then all of the after scores are going to go in variable 2. Now, when we go into stat and our t-test, one of the options is paired. And notice it doesn't have the options of like with summary and without. Like you have to put the sample data in here. So I'm going to have sample 1 is variable 1, sample 2 is variable 2. And we can have it save the differences if we want to. It does before minus after for us, and we have that set up to be greater than 0. Yes, show the critical value there. All right, compute. All right, so our critical value is 1.89. Our degrees of freedom, n minus 1, 7. I guess I could have figured that out in the table. And our t statistic for this is going to be 3.04. I am over here with a p-value of 0.0095, which is less than our alpha. All right, so we say we have significant evidence that sensory scores are lower after the hypnotism. So it must work. That should be a smiley face. Okay, that's your answer.